Hello, today we are going to talk about this GitHub project, the ANDE Meyer mkosi-kernel. This is a tool that's used for developing for the Linux kernel. After you have edited the Linux kernel source code, you use mkosi-kernel to create a Linux kernel image and a very large CPIO initial ramdisk. And then those two things, the kernel image and the init.rd, are going to be booted straight using QEMU without any virtual hard disk. This tool, mkosi-kernel, supports either Fedora Rawhide, which is the default, or Debian testing. So let's get started. There's two steps that you want to do. The first one is to just boot inside of the QEMU virtual machine. And after you manage that, and including you manage to exit the virtual machine, the next step is to put your own Linux kernel sources. There's a ini file. So you specify inside of the ini file where is the path, the full path to your kernel sources. And then you run the same command line again. And this time your Linux kernel will be built and you will boot into the same QEMU virtual machine using the large CPIO initial RAM disk, but with your newly built Linux kernel. Okay, so let's follow the steps for the first part where we boot either Fedora Rawhide or Debian testing. So it says that we should git clone this GitHub repository, which we did in here. Okay. So it's the same Git repository. The next step is to create a file named makeosi.conf in the root of the repository. Makeosi.conf, this one, should have the content distribution, which is a ini file category group, and then a pair of key and value, which is distribution and Fedora, which is the default, or distribution and Debian. Let's try with Fedora first. Okay. And then we need to run this command line. Okay. It complains that mkosi is not found. Let's install it. Okay, is a very old version of mkosi, version 14, which is not supported by mkosi-kernel. This requires a way newer version of mkosi. So let's install mkosi, not from my Linux operating system, which is Ubuntu 2304, but straight from the upstream. So let's undo the installation. Okay, and let's find mkosi. Okay, so it's github.com/systemd/makeosi. There's a release Let's see how we install this thing. We could either install it with pipx or from our operating system, again from the operating system. The mkosi package is too old, so we need the latest and greatest. And then we have this option with a Python venv virtual environment. So let's try to do that. Copy, Ctrl-Shift-V. Says that there's no thing as Python in Unix, in Linux, in Ubuntu 23.04. So we need to specify Python 3 instead of Python. Okay. And then inside of the virtual environment, we're going to use pip to install the latest version of mkosi.kit. Okay. So now we have mkosi, the executable, installed inside of the virtual environment. It's still not available in the path. So let's activate the virtual environment. Okay, so this is the full path to the mkosi executable mkosi. The next thing that we want to do is to go back to this place. And run this command line. Okay, and complains that I'm on Ubuntu and I do not have yum installed. And I totally do not really want to install yum, so let's try to use mkosi-kernel but with the Debian distribution. Name of the file. So this thing should be Debian. And we're going to run the command again. So just make sure that you have the latest version of mkosi available. You git clone mkosi-kernel, create a file which is named mkosi.conf, put inside this content if you're on the family, the Fedora family of Linux operating systems. If you're on the Debian or Ubuntu family of operating systems, then you probably want to put Debian in here. And then you run a single command, mkosi-f-qemu. Okay, and this thing does extremely many things. So it will download hundreds of deb packages, which will be cached locally for speed. It will try to build the Linux kernel from the sources that you provide if you do such a thing. It will create a very large CPIO style initial RAM disk, which is compressed with Z standard as a size of almost 500 gigabytes. But then if this thing is uncompressed, it's 1.4 gigabytes. Okay, and inside it's a initial RAM disk, so a file system image that contains many deb packages installed, like hundreds of them, including systemd, including the OpenSSH server, OpenSSH client, NeoVim, Nano, and in this case, by default, the Linux cloud image from Debian testing. Okay. In this case, everything has moved really, really fast because I have this directory where I have many deb files already cached. So in this run, mkosi-kernel did not really need to download any deb files. Okay, so there's how many files in here? .584 deb files. Okay. After that, it has created the init rd from these packages installed. And then it has started QEMU with the following command line. Let's see if we can see it. So QEMU system x86-64, which means the best possible speed. Hopefully it uses KVM. And then one vCPU, 4 gigabytes of RAM. And then the kernel command line. This thing, image.vm linux, which is this file. This thing, image.vm linux. And then init rd. This image, which is a symlink to image.cpio.z standard. Okay. So inside the virtual machine, this list of the packages is installed. This thing, you can see it in here. Almost 600 packages. Okay. There's no ping in here. Networking does not seem to work by default. Okay, but again, there's NeoVim, which is this guy, and Nano as text editors, and the OpenSSH client and server. Basically, this is a minimal virtual machine that does not contain a virtual hard disk, just an initial RAM disk where you can test if the changes that you made to the Linux kernel source code build correctly, and then run correctly. It's Debian style unified USR. Okay. There's a bit of Python, a bit of Perl. Hundreds of libraries. G++, GCC. Automake, autoconf, autotool, so the GNU toolchain for C and C++ programming languages. Bash, and also part of the LLVM toolchain. So there's clang and LLVM, LLD. Okay. So USR is merged.deb. So that's it, a way to take your changes to the Linux kernel, compile them, so create a binary, and then boot a small virtual machine that's really fast, that uses QEMU, and does not take much resources, so just one vCPU and 4 gigabytes of RAM, does not have any virtual hard disk, and where you can test that the changes that you did to the Linux kernel source code can compile correctly and they run correctly. Again, this, if your changes can be actually tested in a virtual machine, don't require access to real-world hardware. So this was our run of the mkosi-kernel GitHub project. Thank you.